has set a net zero target for India by the year 2070. And cement industries already have the 5 levers for decarbonization: substitution clinkers, alternate fuels, waste heat recovery, improving energy efficiency. Last chapter is newer technology like renewable energy, novel cements, carbon capture and storage. We have already explained that we are generating about 232 million ton fly ash. Out of this, actually, cement plant is using 25%. And slag is completely utilized, granulated slags. So now we are producing about 67% Portland Pozzolana cement, 8 to 10% slags, and we are doing composite cements. A new cement under the shop in NCC runs Portland limestone cement, Portland dolomite cement, and so Portland composite cement having fly ash limestones. So we are going to convert 100% blended cement by the next 3 to 4 years, so that it will indirectly reduce, help in reducing the carbon dioxide emissions. Similarly, alternate fuel and raw materials, it has also improved like anything 2% to 6% THRs. We are using all type of alternate fuel like hazardous and non-hazardous kiln as a replacement of fuel. This is also helping in reduction of carbon dioxide emissions. Similarly, waste heat recovery, the potential is 1000 megawatts. We are doing 540. And energy efficiency, all the cement industries also highly energy efficient, thermal energy and also electrical energy. And our best figure in India is 667 kilocalorie per kg of clinker, and also 56 kilowatt hour for the electrical energy. The last, because all these four areas we are doing well in cement industry, cement sectors. Now it is coming actually. The last is newer technology like renewable energy, novel cement, carbon capture and storage. And we have already collected so many things, technologies which is already implemented earlier, and we will analyze and also implement it. You can see this figure is that the most potential drivers for the reduction of carbon dioxide emission. The target is 0.35 tons of carbon dioxide by 2050. So most clinker factor, how to reduce further clinker factor in the cement, because now we are using about 0.71% clinker in the cement, that will go still reduced, because already we have implemented so many other material we have identified, and also NCC is already doing the research for that. But CCS, without CCS, that we cannot be neutral. That's why the time has already come. We are very happy and also to be associated with this type of seminar where we are getting the knowledge, and also we have collected so many literatures. But our Indian plant and Indian cement industry, also IOCL, they are also doing a lot of things. When the exchange will be there between the cement industry and steel plants and also the oil industry, because we can also learn a lot of things and also we will also implement it. We are also happy to know that actually we have also taken the Ramkumar Sahib with the research advisory meeting in our committee also. We are inviting on 6th April also, come there. Also we will see your plant, how to implement cement and how to replicate the things. So now coming to the capturing the CO2 in cement industries, mostly 3 areas is the post combustions, the calcium looping or chilled ammonia processes or chemical absorption by monoethylenamine, oxy fuel. Lilac project is already there. Instead of air, we can also inject oxy fuel, so that during combustion the replacement of air, and also we can get the good quality of the clinker also. Pre-combustions, coal gasification to grey hydrogen. This calcium looping technology is already implemented and the trial stage and pilot stage is already successful, and the CO2 capture rates is till 98%. But a standard equipment process, it was tested in laboratory scale by Syntef and found very promising. So now we are on the literature survey stage, sir. We are collecting everything.
Chemical looping has been done in your place?
No, sir. We will try it, sir. We have not tried anything in India, sir. It is very infant.
This is global.
We have now collected all the international practices.
Oh.
Then chemical absorption of MEA, then methylenamine plants. Our Dalmia cement, Mr. Singh has already committed that they will go through this process to 2040, because they have already declared that they will be carbon negative by 2050 instead of carbon neutral by 2050. So chilled ammonia processes, these are the different processes that are already applicable and available also in different technology. Lilac technology, similarly low emission intensity lime and cement. This Lilac project is that in the pilot plant at Heidelberg Cement, it is already coming in at Belgium. And here Lilac was a demonstration plant that aims to separate around 1 lakh tons of per year of CO2 in a scalable module. Currently trials are under progress. Next is supply of complete oxygen to replace air also. So in cement plants, this oxygen, pure oxygen can also be put in the burner, calciner, clinker cooler have been successfully tested under the oxy-fuel condition, and the technology is being brought forward. Thyssen Group has already demonstrated a pilot plant, oxy-fuel retrofit and greenfield cement kilns. Grey hydrogen from gasification to fossil fuel, that also in the cement kiln at the British plant at Heidelberg cement plant in UK successfully tested use as a green hydrogen in its main burner. So these are the different technologies already available also in the pilot stage. Post-combustion carbon capture by RTA International, post-combustion carbon capture amine based, then it is carbon clean in UK, then similarly in post-combustion carbon capture adsorption invented Canada, post-combustion carbon capture membrane based liquefaction at Norway, post-combustion carbon capture chilled ammonia process Norway, and improving energy efficiency of building by Conifer, nanomaterials enhanced membranes from the carbon capture by NanoCell, and direct separation of calcium calcinations, that LELAC technology. Then post-combustion carbon capture calcium looping clinkers technology organization, oxy-fuel technology using oxygen in place of air, that is from Norway, post-combustion carbon capture Scarlett, and pre-combustion use of hydrogen fuel in cement industry, that is hydrogen cement pilot scale. Then CO2 utilization, because sir, we are now in the literature survey and also we want to collaborate with the people also how to do it in Indian plants. Then chemistry, mineral carbonation, already so many people have already presented.
Skip all this, skip.
Already slags, mineral carbonation, blast furnace slag, radial slag, electrical furnace slag, paper slag, already it is discussed, and we also do the similar things. Carbonation of concrete, this is most important thing in the cement plant, because whenever we are calcining limestone in the process, the carbon dioxide which is captured, we have to capture it and store it, and that will be utilized in the concrete stream. If that is possible, then also completely carbon dioxide emission can be cured in the concrete, which will give the fresh strength. That is early as carbonation, which involves utilizing carbon dioxide in the production of concrete, when the reaction occurs at a very early stage. In that case, you can get more higher strength of the concrete. You will inject the carbon dioxide. In that case, also carbon consumption in the concrete also could be reduced to get the same strength. So these are the different technology again: carbon pure, carbonate aggregates, carbon concrete composites, Cabicrete, CO2 concretes, fast scrap, Recipiton. These are the already technology available, and already we have formed 22 technological group in NCCBM. One group is already working in this. These are the different technology and mineralization. Then low carbon clinkers. This is the last slide. Actually, we have now, sir, in the different countries, they have already, because since last 60 years, we have not changed the clinker chemistry. The same C3S and C2S running. As a result of which, we have already utilized all high-grade limestones and high energy consumption also.
It's a big problem.
That's why now other countries and NCCBM also we have done a new clinkers. That is ether clinker is developed by the Germany and China. They are using to about 25%. That ether clinker is having the new chemical phases by which there is a reduction in temperature and also carbon dioxide emissions. Solida Technologies in USA, the fellow from India, he is also doing well, Dr. Sahu. The Solida Technology new clinker phases, which will also be cured with the CO2, and also there is a 30% reduction in carbon dioxide emission, and also the energy consumption, less energy consumption. Then Selightment cement, new cement produced at temperature below 300 degrees centigrade. Then Eco Binder, new clinker cement, new light eliminate clinkers. But our institute, NCCBM, the R&D organization under the Ministry of Commerce and Industry, so during last period, we are already doing one clinker we have developed, which is giving the strength, high strength, and also 30% reduction carbon dioxide emission is already there.